Hello, my name is Mumcuoğlu. I'm a freshman student in Electrics and Electronics Engineering in Bilkent University, and today I'm going to be presenting you my Physics 101 lab project. The aim of my project is to examine and obtain Earth's gravitational constant in Bilkent University and to observe the possible difference between the gravitational acceleration constant on the Earth's surface and Bilkent University.
And this is my lab equipment. This is the stopwatch. I'm going to be examining the time of the fall. This is the roll meter. I calculated the difference heights of each free fall experiment with it. And this is my steel ball. I'm going to be throwing this, and this is the mat. I'm going to be throwing my ball to the mat in the certain heights.
This is the gravitational acceleration formula I'm going to be using. I took the vertical axis as my x-axis and its positive direction is from the ground to the sky. X here indicates the final position of my object, which is the ground, which is chosen as 0. X sub 0 indicates the initial position of my steel ball, which is the chosen heights of the free falls. V sub 0 indicates the initial velocity of the object, which is 0. A indicates the gravitational acceleration constant in my location, and T indicates the elapsed time of free fall in each experiment. When I put the data I obtained from my experiment into this formula, I will temporarily obtain my gravitational acceleration constants as negative, which will indicate the decrease in the position vector. But for the rest of the experiment, I will use their positive forms. I executed 8 freefall experiments from different heights with my experiments set up, and here are a few of them.
So in the beginning, we're going to throw our ball from 1 meter exactly.
I executed my experiment by choosing different heights for each of the 8 free falls of my steel ball, calculating the exact height with the roll meter, and calculating the elapsed time between the release of the steel ball and its impact with the ground, and note these numbers in order to use them for the calculation of the gravitational acceleration constant of each scenario.
So from 1 meter, the time is 0.44 seconds. This time 1.4 meters free fall. Again, 0.53 seconds for 1.4 meter free fall.
As you can see in this table and in the following chart, the experiments number 1, 4, 5, and 7 were higher, and experiments number 2, 3, 6, and 8 were lower than the theoretical gravitational acceleration constant that has been obtained from the gravitational acceleration calculators, which is 9.7989 meters per second square. Next, I took 8 experimental gravitational acceleration constants average as my main gravitational acceleration constant in order to minimize the error in my experiment, and finally, I compared it with the theoretical acceleration constant. Finally, I calculated the average of 8 gravitational acceleration constants as 9.8225 meters per second square, which is higher than the theoretical gravitational acceleration constant. In my experiment, the causes of the difference in Earth's theoretical gravitational constant on Bilkent University and the experimental gravitational constant on Earth on Bilkent University were found as small amount of air friction acting on the object during the free falls, low precision of the calculation equipment, and researcher-based errors during the calculations, such as not being able to stop the stopwatch at the exact time of the impact of the ball with the ground during the experiment.